We're going to be proving triangles congruent in this lesson, and today we're going to be looking at two proofs. Before we get to the proofs, we need to look at two definitions that we have done already in this course. One is the bisector of a segment. Now remember, that's a line, a segment, a ray, or plane that intersects a segment at its midpoint. So if this is my midpoint, that is the location where the segment, line, ray, or plane is going to intersect the given segment AB at its midpoint. Now we're looking at the midpoint definition of a segment, the point that divides the segment into two congruent segments. So if my midpoint is here at M, I know that segment AM is congruent to segment MB. Now I know these definitions are definitely related, but the one thing that's going to be important in proving triangles congruent is that the definition of midpoint, the way it reads, is we are dividing things into two congruent segments. Okay, let's look at our first proof for today. The given information is that segment DC bisects segment AB, and our second given statement is segment AC is congruent to segment BC. Now, what am I trying to prove? That's always what we need to keep an eye on. Here's my proof statement. I'm trying to prove that these two triangles are congruent. The triangle ADC is congruent to triangle BDC. So let's look what we have already written in the proof. We have segment AC is congruent to segment BC. That's given, as we know. So once we write it in our proof, I like to then mark the diagram. So I have AC is congruent to BC. Now the second given statement says segment DC bisects segment AB. Now remember in the definitions we just looked at, the bisector, although it does help us in dividing segments, it doesn't talk about congruency. So what do I know from that? Once I say that segment DC bisects AB, I can say that D is the midpoint of segment AB. And why is that true? Remember, we're always going to the previous step. That's because it's the definition of a segment bisector. Now, in step 3, since we're talking about midpoint, I now know I can go to congruency. So I can say, because D is the midpoint, here's point D, is the midpoint of segment AB, I can say that segment AD is congruent to segment DB. Now, why can I say that? That's because that's the definition of a midpoint. Now again, I'm going to mark that in my diagram. AD is congruent to segment DB. Now the other thing I'm going to do while I'm working on my proof in here, I want to mark what I have so far. So in step number 1, that's a side. I showed that a side was congruent. And in step number 4, I also showed that I have a side congruent. So I have two sides. I need to either look for another side or an angle in the right spot in order to prove that these triangles are congruent. So my last piece that I'm looking for, I do notice that segment DC is what we call reflexive. Segment DC is part of triangle ADC, and it's also part of triangle DBC. So therefore I can say that it's congruent to itself. So I say that segment DC is congruent to segment DC congruent to itself, and that's because of the reflexive property. So I'll mark that. Now I have 3 sides. So I'm ready to prove that my triangles are congruent. So I have triangle ADC is congruent to triangle BDC, and the reason I can say that is because of the side, side, side postulate. In our next proof, we have the given information as segment RC is perpendicular to segment ST, and segment TU is perpendicular to segment ST. We also know that V is the midpoint of segment ST, and again, I'm trying to prove that those two triangles are congruent. So in step number 1, I combined 2 of those given statements, and the reason I combined those 2 and not the third one is because those 2 have similar ideas. They're both talking about perpendicular lines. So what do I know about perpendicular lines? Well, I know where they meet, they form a 90-degree angle. So that's going to be my next statement. I know that segment RS is perpendicular to segment ST, so I'll mark that. I also know that segment TU is perpendicular to segment ST, I'll mark that. So by that I can say that the measure of angle S is equal to 90 And I also know that the measure of angle T is equal to 90. Now, why can I say that? Again, I'm always going back to my previous statement. I can say that because of definition of perpendicular lines. Now, what do I notice about that? I notice that since the measure of angle S and the measure of angle T are both equal to 90, I can say that they're equal to each other. So the measure of angle S is equal to the measure of angle T, and that is because of substitution. Now, because they are equal to each other, they're also congruent. So I can say angle S is congruent to angle T. Now, in some books or some teachers like you to list that as a separate statement, but I just put them together. So I know now that I have substitution. I also notice now that I have a pair of angles that are congruent. So I'm going to mark that. Here is my red. I already have that marked as 90, so I'm just going to identify the fact that that means that they're congruent. Now let's look at the next given statement. So I had that V is the midpoint of segment ST. So again, that's given. Now what does that mean? Again, we worked on this in the last proof. If I say something is a midpoint, I know that it's dividing the segment into two congruent segments. So that's what I can say next. I can say that segment SV is congruent to segment VT, and that is because of definition of a midpoint. Now again, it's in my proof, so I'm going to mark my diagram. So SV is congruent to VT. I also want to mark that I have a segment here, a pair of segments that are congruent. So I need one more thing, and what do I notice? Well, in looking at the next step, and then back to my diagram, I notice that I have a pair of vertical angles there. So I can say that angle RVS is congruent to angle TVU, and that is because vertical angles are congruent. So now I'm going to mark that I have another set of angles. So I have to see if I have it in the right order. I have angle, I have an angle here, and then a side, and then an angle. Same thing on the other side, angle, side, angle. So I have three pieces of congruency, so I'm now ready to prove my triangles are congruent. So I have triangle RSV is congruent to triangle UTV, and that is because of angle, side, angle postulate.